EcoTailor is a daily planning system for negotiating actionable low-carbon schedules. It helps people create daily plans that are both sustainable and practical. We all know what are the environment-friendly choices, but knowing is not the same as doing. Every day, carbon saving competes with many other priorities: our time, social plans, responsibilities, and even the weather. When these priorities take over, it's much harder to make a greener choice, even though we know which choices are better for the environment. Previous works have developed systems that suggest a sustainable option at the point of decision, but people may still be unable to choose it. Real world constraints such as time pressure or existing commitments often outweigh the intention to reduce carbon emissions. So, how can we make low carbon choices actionable in everyday life? We see two key requirements. First, respecting real life constraints, and second, negotiating schedule changes that remain acceptable to the user. Now, let's see how these principles can be applied in practice. Take Maya as an example. Today, she has a study plan and a dentist appointment. She is usually comfortable with walking for up to 30 minutes. These are the kinds of real life constraints and preferences that should be considered when planning her day. By taking these constraints and preferences into account, we can explore multiple schedule alternatives. Some plans may reduce more carbon, but require changes that are too difficult to accept. Instead, the goal is to find the most actionable option that balances carbon reduction with the user's everyday constraints and preferences. To put this idea into practice, we designed and implemented EcoTailor, a daily planning system for negotiating actionable low carbon schedules without compromising existing routines and commitments. Here's how it works. At the end of each day, users enter their plans for the next day into EcoTailor. Some events are fixed and require a specific time and place. Other events are flexible, meaning their time or location can be adjusted. Users can also specify their preferences, such as preferred transportation options or maximum walking time. Once everything is set, the scheduler creates multiple alternatives based on the user's fixed events, constraints, and preferences. Users can adjust the willingness factor, shown as today's carbon reduction goal, to explore schedules that better match their desired level of carbon reduction for that day. If none of the suggested schedules feel suitable, they can simply generate another set of alternatives. To evaluate whether EcoTailor works as intended, we conducted both an in-lab study and a deployment study. The in-lab study was a between-subjects experiment comparing an awareness-raising condition with the EcoTailor condition. The awareness-raising condition provided in-situ reminders of general carbon-friendly options. Participants completed both self-paced and persona-based planning tasks. In the deployment study, participants first went through a 2-week observation period living as usual, followed by a 2-week EcoTailor period using the application. We then compared their carbon emissions between the two periods. One of our key interests was how EcoTailor affects carbon emissions. In the in-lab study, participants using EcoTailor achieved significantly greater carbon reductions than those in the awareness-raising condition. The deployment study further showed that these reductions also occurred in everyday life. Beyond the overall reduction in carbon emissions, we further explored two questions. Where did the carbon reductions come from, and how did carbon emissions change from day to day during the deployment study? We identified two main sources of carbon reductions. The first comes from transport-oriented changes, and the second from event-oriented changes. In the first example, the user originally planned to take a taxi between the seminar and the study session. However, there is already enough time between the two events to take the bus instead. In this case, EcoTailor recommends changing the mode of transportation from taxi to bus. The second example is an event-oriented change. In the original schedule, there is not enough time to walk from the workshop to the study session, so the user has to drive. But EcoTailor identifies that study is a flexible event and that adjusting its timings make walking a feasible option without violating the user's constraint. Accordingly, EcoTailor generates this schedule and suggests it to the user. Next, we turned to our second question: how do carbon emissions change from day to day in the wild? We observed different patterns across participants. Some participants consistently reduced their carbon emissions, while others alternated between reductions and increases. The interviews provided further insight into these variations. Participants noted that what was feasible could change depending on how they felt and what conditions they faced that day. EcoTailor helped them adjust their plans accordingly and find carbon reducing options they could realistically follow. The key takeaways are as follows. First, people face different constraints and different opportunities for change. Second, supporting actionable behavior requires personalization rather than a one size fits all solution. Third, actionability is dynamic. It changes from day to day depending on people's willingness and everyday context, making continuous negotiation essential. EcoTailor is one example of how systems can support this kind of personalized negotiation while preserving people's existing routines, responsibilities, and commitments. Thank you for your attention. For more details, please see our full paper.